configuration is common collector configuration. You can see in this configuration, collector is common to the input side and to the output side. Collector is common to the input side and it is also common to the output side. VBB and VEE are the biasing potentials. IB is the base current, IE is the emitter current, and IC is the collector current. We are using NPN transistor in active mode. Because of this, emitter base junction is forward biased and collector base junction is reverse biased. We can also represent the common collector configuration using the symbol of transistor. I will quickly draw the symbol of transistor. We are using common collector configuration. That's why collector is common. This is emitter. For NPN transistor, this is the direction of current. This is base. This current is base current IB. This current is emitter current IE. And this current is the collector current IC. The input voltage is VBC, and the output voltage is VCE. VCE is equal to VBE plus VBC, and the input current is IB, the output current is IE. In case of output characteristics, we plot the graphical relation between the output current IE and the output voltage VCE for different values of input current IB. So we have the graphical relation between the emitter current versus voltage VCE for various levels of base current IB. Now there is one very important thing that we are going to conclude. We know IC is equal to alpha times IE. Alpha is from 0.95 to 0.98, which is nearly equal to 1. So we can say that the collector current is nearly equal to the emitter current. So we can replace this emitter current with the collector current. And if you remember the last presentation, the graphical relation between the collector current IC and the voltage VCE for various levels of base current IB is nothing but output characteristics of common emitter transistor. So for all practical purposes, the output characteristics of common emitter transistor is similar to the output characteristics of common collector transistor. This is very important point. The next thing is the current amplification factor in common collector transistor. The current amplification factor is denoted by gamma. The current amplification factor is denoted by gamma, and it is ratio of change in emitter current to the change in base current. It is equal to ratio of change in emitter current, the output current, to the change in base current, the input current. We already know the emitter current IE is equal to the collector current plus the base current, and the collector current IC is equal to alpha times IE plus ICBO. This is equation number 1 and this is equation number 2. I want to see how output current, that is emitter current, varies as function of input current, that is base current. I will use these two equations, and by using them I have IE equal to alpha times IE plus ICBO plus IB. I got this by substituting the value of collector current in the first equation. I can further simplify this as 1 minus alpha IE equal to IB plus ICBO. Now I will divide both the sides, the left hand side and the right hand side, by 1 minus alpha. So we have IE equal to 1 divided by 1 minus alpha IB plus 1 divided by 1 minus alpha ICBO. 1 divided by 1 minus alpha is the current amplification factor in the common collector configuration. This means IE is equal to gamma times IB plus gamma times ICBO. So this is what we have in common collector configuration of a transistor. In the next lecture, I will derive the relation between alpha, beta and gamma. So see you in the next presentation.